Hey everyone! So in the first video we talked about types of data and types of variables, and we said that the two types of data we're going to focus on for the histoprogram are continuous data and nominal data. And we also had two types of variables, dependent and independent variables. Well, what I'm going to show you today is something called a bestiary of statistical tests, and what this basically does is tell you, depending on the types of data you have for each one of your variables, we can determine which tests we want to run. So in this figure, I'm going to put along the top our dependent variable, which is y, and I'm going to put independent over here, which is x. Okay, so for both types of variables, we have, sorry, my cat got in the way. For both types of variables, we can have either nominal or continuous data. So I'm going to have nominal and continuous. And the same thing here, nominal and continuous. Alright, so what we have now is a working figure where we have dependent variables across the top. They can be either nominal or continuous. And we have independent variables along the side, and they could also be nominal or continuous. So I'm going to show you the four types of tests you can run based on these types of data. And I'm also going to explain to you the null hypotheses of each test. So let's start with a test that looks at nominal dependent variables and nominal independent variables, and what we would call that. So we're going to call that a g-test or chi-squared. So chi-square. Alright. And what this test does is it tells you the proportion of groups A and B. So we would get a figure that looks something like this, where we have our dependent variable y on the y-axis, and this is a proportion. Then we have our independent variable x along the x-axis, and we can have multiple levels of this independent variable. I want to start with two levels, A and B. So our null hypothesis tells us that, let me write it out here for you, H sub O, null hypothesis, there's no difference in the proportions of group A and B. So no difference in proportion of A and B. And we do this when we have two variables, a dependent and an independent, that are both nominal, so they're both categories. Okay? And we'll go through these tests in more detail later on in videos. But let's move now to a type of test that looks at a nominal dependent variable and a continuous independent variable, and this is called a logistic regression. Logistic regression. And logistic regressions typically look at yes-no data, so the dependent variable would be, did something happen, yes or no, perhaps did something survive or die. And what we would see for that figure, our y-axis would be, let's just go with yes and no. And then our x-axis would be a continuous variable. So our null hypothesis with this would be that the slope of the line that we fit equals 0. So say we have a lot of points, and we fit a line with a slope equaling 0. I'm sorry, let me take that back really quickly. So with a logistic regression, we're not going to have points in the middle because we either have yes or no answers. Got a little confused there. So we have a no response and a yes response, but our null hypothesis is what? Well, our null hypothesis is that the probability of getting a no versus a yes answer does not change as a function of our independent variable. Okay, so Let me see if I can write that out very small. Probability of getting yes or no does not change, and this little triangle is a change symbol, as a function of our independent variable. Okay, and like I said, this can be survived or died. It can be a lot of different things. So that's our test when we have a nominal dependent variable and a continuous independent variable. Let's move to the top right, where we have a continuous dependent variable and a nominal independent variable. We call this analysis an ANOVA, and this stands for analysis of variance. And there are a lot of different types of ANOVAs we could do, actually. We can do a one-way ANOVA, a two-way ANOVA, three-way ANOVA, nested ANOVA, ANOVAs without replication, but we're going to focus for the histoprogram on one-way ANOVAs and two-way ANOVAs, okay? But the null hypothesis for both is exactly the same, and that is that there's no difference among means. All right, no difference among means. And what would our null hypothesis look like in a figure? Well, we'd have our dependent variable on the y-axis, and this would be continuous. So this could be, let's say, between 100 or 0 and 100, but it doesn't have to be between those two numbers. Then we'd have our independent variable on the x-axis. And for this, we would have different groups, different categories. So in this case, I have 3 levels of that independent variable, level A, B, and C. This could be 3 different populations from which plants were drawn. It could really be anything, but it's a category. And for a null hypothesis, we would see that the means of these different categories, these different levels, do not differ. All right, so a continuous dependent variable, a nominal independent variable. So the last one we're going to look at is when we have a continuous dependent variable and a continuous independent variable, and we use a regression to analyze this type of thing. All right, so with a regression, very similar to our logistic regression, our null hypothesis is that our slope equals 0. And what does that look like? So we'll have our dependent variable on the y-axis, and this can be between any two numbers. It's continuous. And we'll have our independent variable on the x-axis, and that can also be between any numbers. So it's a continuous variable. And our null hypothesis, where the slope equals 0, would look something like this, where we have our data points and our fit line has no slope. It goes straight through them with no slope. All right, so what kind of questions do these ask? Do these statistical tests answer? Well, for up here in the top left, the chi-squared, we're wanting to know, is there a difference in the proportion of groups A and B? Difference in the proportion of whatever we're measuring in groups A and B. For our logistic regression, we're saying, is the probability of getting a yes or a no answer, or a survived or died, change as a function of x? For ANOVA, we're trying to determine if there's a difference in the means among our groups, so among the different 3 levels. And with a regression, we're going to ask, how does the dependent variable, our y variable, respond to changes in our x variable? So it's a cause and effect relationship. There's another type of test that I want to talk about that's not included in that bestiary list, and that's because it actually does not have an independent and a dependent variable. It actually has 2 dependent variables. So correlation is the last one I'll talk about, and this is really the association of 2 dependent variables. So we're going to have a figure that looks something like this. Here's our first dependent variable and our second dependent variable. Now here, we're not trying to put together a cause and effect relationship. We're just trying to see if these two are associated in any way, right? So, our null hypothesis for a correlation is basically what my advisor and biometry professor taught me, a shotgun splatter of points, where they're not correlated negatively or positively in any way. And you'll learn this in further videos, but because we're just doing the association of two dependent variables, we can easily change these axes. It doesn't matter which variable is on which axis because we're not implying a cause and effect relationship. Okay, so, I guess one thing I forgot to mention, which is very important, with correlation, these two dependent variables that we're talking about are both continuous. So both continuous. Y1 could be 0 to 50, Y2 could be 0 to 100, and vice versa. So correlation has two continuous dependent variables. So I think that's all the tests we're going to cover in this video series. If I were you, and I have it multiple times in my notes from class, I would be sure to make a note, even make a little drawing of that bestiary table, because it's really going to come in handy when you're trying to do your research in the future. All right, guys, I will talk to you next video. Thanks so much.